Okay, so we are now recording. Start sharing the screen. All right, I'm actually considerably ahead. I was only supposed to go up to 1.3. I'm probably going to do 1.4 and even finish it. Okay. So if that's the case, there's only, quote unquote, 1.5 left, but 1.5 is a pretty big section. Okay, so we should finish in plenty of time for the test next Friday. And it may look like I may even start sneaking in some of the next chapter, which is calculus proper. We would begin calculus per se. Okay, now for today, I wasn't going to have you do an in-class assignment, except I do want to find out if any of you have had some background in calculus. So on the way out the door today, your quote-unquote in-class assignment is just tell me, have you taken calculus in one way, shape, or form before, whether in college or at high school? Have you had some background in calculus? So I know how to approach this. For those of you that have had calculus, you're going to be a little bit, shall I say, disadvantaged. I kind of want you coming into the class not knowing any calculus, because you're going to want to do some shortcuts. Okay, so those of you who have some calculus background, you want to do some shortcuts when it comes to chapter 2, but you're not allowed to do that. Okay, if such a thing were possible, I wish I could just zap all of you and take away any of your previous knowledge of calculus. That's what I want you to have, so to speak. Okay, and your prior background of calculus kind of, quote unquote, gets in the way, so to speak. Okay, so we'll just keep that in mind. So I'm not going to give you an in-class assignment today, except just on your way out, have you or have you not had some calculus in the past? So that's all I'll be asking you. Okay. All right, so 1.4 is on exponential functions. So we're reviewing exponential functions, page 45. Okay. An exponential function looks like f of x equals b to the x power. Okay. That's an exponential function. B is a base. We require it to be positive, and we don't want it to be 1. If the base is 1, it's too trivial. 1 to the x, 1 raised to anything is 1, so that's too cheap. Okay, so the base is positive, and the variable is x. So 2 to the x, 3 to the x, 10 to the x, pi to the x, 1/2 to the x, those are exponential functions. Okay, please notice that's not, if you reverse it, if you have something like x squared, I can't write it for you because I'm carrying the book, but if it says x squared, that's not exponential, that's a power function. Okay, so not x squared, but 2 to the x. So a variable in the exponent. The variable is the exponent, and a constant is the base. Then that's considered an exponential function. Okay. So here's an exponential function, 2 to the x. F of x equals 2 to the x power. X is a member of the real numbers. Okay, there's our abbreviation for real. It's a funny looking R. Just draw 2 lines there. Okay, so exponential functions tend to look like that if the base is greater than 1. Okay. Now here's a whole family of exponential functions on page 47. Okay, I'm going to try to hold it up a little bit so you can see it. Okay, notice all the bases are considered positive. You run into a little bit of problem when you start having negative bases. Okay, so we only want positive bases. Okay, here's 1 to the x. Well, you know 1 to the x is always 1, so we don't usually discuss that. It's kind of cheap. Okay, so look what's happening here. It looks like for the bases that are bigger than 1, the graph is increasing. It's going up. The bases that are smaller than 1, like 1/2 to the x, 1/4 to the x, they're all decreasing. Okay. So here's a characteristic of exponential functions. Please notice the variable is the exponent. So notice that x is floating up there. Okay. So it's not the other way around. So in other words, this is 2 to the x. that's exponential. If I switch it around and say x squared, that's not exponential. That's a power function. Okay, so exponential is constant base variable exponent. Okay, now, I noticed one thing. They all seem to go through the same point. Can you see what that common point is? Hint, for any of these, what happens when you plug in 0? 1. Anything to the 0 is 1, right? So they all go through 0, 1. Okay. And yeah, let's look at the progression of what happens. Okay, so let's look on this side. Stuff for x bigger than 1. 1.5 to the x, 2 to the x, 4 to the x, 10 to the x. So the bigger the base, the steeper it goes, it looks like. Which kind of makes sense. I mean, even if I plug in a number as easy as 1, if I raise anything to the 1, it's the same thing. So this one, the y value would be 1.5. That would be 2. That would be 4. That would be 10. So we know it's higher here. And same thing over here, right? 1/2 to the x, 1/4 to the x. Okay. But notice what happens on this side. Okay. They kind of trade places. Okay. So if you can kind of see the black one, it's the lowest one here, but it's the highest one here. And as you can see the yellow one, it's the highest one here, but it drops the lowest here. So after they pass through the point 0, 1, they switch places. Okay. So less steep, steeper, 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 but they reverse over here. Now on this side, 1.5 to the x is higher than 2 to the x, which is higher than 4 to the x, which is higher than 10 to the x. Okay. One way you can show that is to plug in a number like -1. 10 to the -1 is 1/10. That's lower than 1/4, which is lower than 1/2, which is lower than 1 over 1.5. Okay, same thing here. If you look at 1/2 to the x and 1/4 to the x, okay, 1/2 to the x is here, 1/4 to the x is here, and then past 0, 1, they trade places. Okay, this one was on the higher part, but now it's lower, and same thing with that. Okay. For all of these, except for 1 to the x, okay, I'm not going to count 1 to the x. Pretend it's not even there. What will be the domain of the exponential function? The domain is all real numbers. What do you notice is the range? The range is positive numbers, or from 0 to infinity, not counting 0. Okay? So the thing that comes out of an exponential function is only a positive number. Okay? Can't be negative, can't be 0. So the domain is 0 to infinity. All right, page 47, properties of exponents. You've already known this, you know. I really don't have to spend too much time on this. You've known this since algebra 1, basically. B to the x plus y is b to the x times b to the y. B to the x minus y, b to the x over b to the y. B to the x to the y, you can multiply these, b to the xy. And then a more complicated base, ab to the x, you can kind of distribute the x, a to the x, b to the x. Okay, I don't think I have to spend any time on this at all, since you've seen this in algebra 1, algebra 2, pre-calc, you know, so you've seen it in at least 3 classes, I'm guessing, the laws of exponents that you're familiar with, hopefully. Okay, then we're going to sketch the graphs of some of these using some of the rules we had before, right? So we're going to use reflection properties, translation, move left, right, up and down, and so on. Okay, and that's the basic idea behind this section. So for instance, on page 48, there's 2 to the x, negative 2 to the x, reflect across the x-axis. 3 minus 2 to the x, just move this graph up 3. So the asymptote, which used to be the x-axis or y equals 0, becomes y equals 3. Right? Okay. Quick word. You do want to get comfortable with the number e. We'll be doing e to the x a lot. In fact, once we get going with the calculus, e to the x is going to be our favorite exponential function. We're not going to like 2 to the x, 3 to the x, 10 to the x. We like e to the x the most. Okay. We don't know why yet, but we'll see eventually. Okay. So of course on your calculator, if you have a calculator like this, a TI series, e to the x is normally above the ln button. So maybe like right there, e to the x and ln or ln x. If you just have a regular scientific calculator, same thing. Let's see, there's ln and there's e to the x. Not sure you can see it there. E to the x. Okay, now how much is e? E is about 2.7. Okay. Now, if your calculator does not have an e button, which mine doesn't, you can show the value of e by doing e to the first power. So let me just show you e to the first. Second function, e to the first power. And there it is, 2.71828, blah, 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 blah. Okay, e is an irrational number, like pi, never terminates, never repeats. So pi, we usually just say 3.14, but it's really 3.1415926, blah, 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 blah. So e, what do you need to know about e? Well, maybe just 2.7, but it's really 2.718, blah, 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 blah. Okay, it's an irrational number. All right, so e to the x. So there's a graph of 2 to the x, e to the x, and 3 to the x, which kind of makes sense. E is about 2.7, so that means e to the x should lie between 2 to the x and 3 to the x, right? So if we look at this part, the part where x is greater than 0, 2 to the x is on the bottom, e to the x is next, and then 3 to the x. It looks like e to the x is hugging pretty tightly to 3 to the x. Well, that kind of makes sense because e is like 2.7, so it's closer to 3. And again, notice on this side they switch, right? So the blue 2 to the x was on the bottom on this side, but it's on the top on this side. And likewise, 3 to the x was on the top here, it's on the bottom on this side, and the red one stays in the middle. Okay. All right, so we're ready to show you some problems. Okay, so I'll go right to the homework, do a bunch of them. So 1.4, just 1 to 21 odd, that's all we need to do. Okay. And then after that, we only, quote unquote, have 1.5, but you can see 1.5 is a pretty big section. But that's the last section leading up to the test, which again is Friday the 5th of February. Okay, so this Friday, we'll have our quiz, just like the first quiz. I'll break you into your breakout rooms, but then the Friday after that will be our first exam. Okay, so I'll get started with the homework. I do see some stuff in the chat, so let me see if I can address that. Okay, so, yeah, okay. All right, so I think we're good. Just some procedural options. All right, so let's get started with the homework. So 1.4, and again, let me show it to you for those of you who never want to buy the book. And by the way, if I ever forget to do this, somebody put in the chat or holler or scream at me. Yeah, it is my game plan to show you all the homework pages for the whole semester, saying, man, I don't want to buy the book, it's too expensive and all that stuff. I will show you the homework, at least I'll try to, unless I forget. So if I ever forget it, and you're of the opinion you're never going to buy the book, and I forgot to show it to you, then just remind me, and I'll try to remember to do that for you. Okay, so we only have to do 1 to 21, page 53. Okay, so there's 1 through 4. There's 5. Obviously, if you already have the book, then you're good. Okay, 7 and 8. Okay, again, if I'm going too fast, you can always look at the video later. 9 through 15-ish. 17. 19. And then 21. I guess I got to change the page. 21. There it is. Find the exponential function whose graph is given. Okay. So there we go. All right, a lot of this is review, so I don't think it's going to be too big a deal. Okay, number 1. A, 4 to the negative 3rd over 2 to the negative 8. All right, so you might recall properties of exponents. When you have a negative exponent, you can change the location. Okay, so if a negative exponent is a numerator, you can bring it into the denominator as a positive exponent. And likewise, if you have a negative exponent in the denominator, bring it up to the numerator and make it a positive exponent. So 4 to the negative third becomes 4 to the positive third on the bottom. And then 2 to the negative 8, which was in the bottom, can come up as 2 to the 8th. Okay, and yes, you could punch that in a calculator, I thought I'd show you another technique. Okay, another trick is to get both of these to be the same base. Okay, now I know that 4 is equal to 2 squared, right? So do you agree that's still 4? 2 squared cubed. And then when I write it like that, I can multiply the 2 times the 3. So 2 to the 8 divided by 2 to the 6. And then I just use the property that I can subtract the exponents. 2 squared is equal to 4. Okay, so that's what I would do if I was not able to have a calculator. You can punch that in the calculator, but I thought I'd show you this, a trick to avoid that. Okay, B, all they want you to do is rewrite it as a fractional exponent. So 1 over cube root of x to the 4th. Okay, so you might recall as a fraction, this is the power and this is the root. So you don't do anything with the 1 over. Okay, so x raised to the power divided by root, so 4 over 3. So 1 over x to the 4/3 is my answer. Okay, so power over root. So be comfortable going both directions. If they write it like that, you should be able to write it like that. Power over root. Okay? So if they give it to me like this and they say write it as a radical, then 4 goes here, 3 goes here. Power over root. If you forget that, put it on your cheat sheet. Okay, a memory trick that I like to have is the root. If you think of the root of a tree or the root of a plant, it's down, right? Further down. So this one's kind of down more, the root. So that's that. Okay, 3b, 6y cubed to the 4th power divided by 2y to the 5th. Okay, so I can distribute the 4. I raise 6 to the 4th power, and I raise y cubed to the 4th power. Okay. Y cubed to the 4th, you're allowed to multiply these. 3 times 4 is 12, so I have y to the 12th. And yeah, this one, just punch it in your calculator. So 6 to the 4th, 6 times 6 times 6 times 6 divided by 2 comes out to be 648. And then y to the 12th divided by y to the 5th, I subtract the exponents, y to the 7th. So final answer, 648, y to the 7th. Okay. All right, so these are some of the problems. Okay. Again, I try to show you enough that you know how to do the rest of them. So I did 1A, 1B, and 3B for you, right? I think you can figure out the other ones that I didn't do. Okay, now some graphs. Okay, now for this class, anytime you see this little graphing calculator icon, you can just ignore it. Okay, I do want you to graph it, showing the relative positions. Okay, but I'm not requiring you to have a graphing calculator. If you already have a graphing calculator, that's fine. You're not supposed to use it for the exam. I guess you can use it as double check. But your primary means of graphing for this class should not be a graphing calculator. So in other words, if I say graph the function blah, 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 you just type it in and draw the graph and you don't show anything else, no credit, okay? So I will make the assumption you do not have a graphing calculator and you'll do techniques of calculus to draw the graph of whatever. Okay. Okay, so, well, 7 and 9, graph on a common screen. How are these graphs related, right? So 2 is smaller than E, 2.7, smaller than 5, smaller than 20, right? So you just basically have to make it look like this, right? Just have the progression like this. So it would be, I forgot what they were, 2E and that and that. And then on this side, make sure they switch. The highest becomes the lowest and the lowest becomes the highest. Right? So that's the game you play with 7, and I will show you 9 in its entirety. Okay, 3 to the x, 10 to the x. So we know what that's about. And then 1/3 to the x, 1/10 to the x. Base is smaller than 1, so we should know what that's about. Okay, now all of these should go through the same point. What common point is there? Hint, what happens for all of these when you plug in 0? You get 1. So here we go. 3 to the x, 10 to the x, 1/3 to the x, 1/10 to the x. Okay, let me just do 3 to the x and 10 to the x. So 3 to the x is lower than 10 to the x. Okay. Again, one way you can get that is if you just plug in an easy number like 1, right? You plug in 1, this is 3. Plug in 1, this is 10. Well, 10 is higher, so it goes like that. So what does it mean on this side? Which is the higher, the green or the blue? The blue, you switch, right? So the blue is now higher. Sorry, the blue is lower and the green is higher. Okay, how about 1/3 to the x, 1/10 to the x? And I think it might be easier to think of this side first, where x is positive. So 1/3, 1/10. If I plug in 1, which is bigger, 1/3 or 1/10? 1/3 is bigger than 1/10, right? So I've got it in black. This one is higher, so the black is higher than the red. That means on this side they switch. Okay, so there we go. All right, so the blue one is 10 to the x, green is 3 to the x, and the black one is 1/3 to the x, and the red one is 1/10 to the x. Okay, so get the relative position for x greater than 0, and then reverse them for x less than 0. Okay. Now, the problem's actually finished, but I'm going to dig a little deeper. 1/3, you can think of it as 3 to the negative 1, which means it's 3 to the negative x. Likewise, 1/10 is 10 to the negative 1. Then if it raises to the x, it's 10 to the negative x. Okay. So recall what happens when you replace x by negative x? You get the reflection across the y-axis. Okay. So if you look at 3 to the x and 1/3 to the x, which is the same as 3 to the negative x, they are the reflections of each other. Okay, so I go like this. So let's see. The green one and the red one. The green and the red are reflections of each other across the x-axis. Likewise, 10 to the x and 10 to the negative x, or 1/10 to the x, the reflection of this graph is this graph. Because 1/10 to the x is the same as 10 to the negative x. And recall, if you replace x by negative x, you just get the reflection across the y-axis. Okay. Okay, 11, 13, 15. Make a rough sketch. Do not use a calculator. Use the graphs and transformations of functions. Okay, so you should be able to show me the progression of the transformations, of course. So 11 should be fairly easy. 4 to the x minus 1. Okay, so you should be able to draw me 4 to the x. It's increasing. When would the graph be decreasing? Base is smaller than 1, like a half or a third or 0.9. But as soon as you get a base bigger than 1, even 1.1, or anything as big as a million, it's going to increase. And this is 0, 1. All right. Think of what happens if I do minus 1. How is it translated? And yes, when I say the word translate, it means move. Okay. Of course, when you and I hear the word translate, we usually think of translating a language. Okay. But you can look up in a dictionary. Translate also means to move. So I can translate this graph. I move it 1 unit down. So 0, 1 becomes the origin, and there's 4 to the x minus 1. The asymptote also moves down. So the asymptote used to be the x-axis, which is y equals 0. Now it moves down to y equals negative 1. Okay. So remember, from pre-calc, hopefully, an asymptote is a line that the graph approaches. Okay. technically it's not true that the graph doesn't touch an asymptote, although that does happen a lot. Okay, so we just say it's a line that the graph approaches, period. Okay, so 4 to the x, 4 to the x minus 1. Okay, 15, I was going to show you the progression. There's quite a bit going on. Y equals 1 minus a half e to the negative x. So you can see I got a whole bunch of graphs here for that. And again, you should be able to show me such a progression on homework or quiz or test. Okay, so how do I graph 1 minus 1 half e to the negative x? So I start with my basic e to the x. Okay, e is like 2.7, so it increases. E to the x. Then I go to e to the negative x. Reflect across the y-axis. So here's e to the negative x. So the mirror image of this one is this one. Okay, so put a mirror right here. I know it crosses, so maybe it's easier to think of it in parts. If I just take this part here, the mirror image would be that. And likewise, the mirror image of this part would be this part. So this is e to the negative x. Still goes through 0, 1. Now, what if I put a minus sign in front of it? Negative e to the negative x. That reflects across the x-axis. So this one bounces down to here. So the one I have in red now is negative e to the negative x. Which means instead of 0, 1, the reflection is 0, negative 1. 0, negative 1. By the way, what happens when you plug in 0? E to the 0 is 1. The negative sign makes it negative 1. Now, then I progress to negative a half e to the negative x. Negative a half, well, that shrinks the graph. That pushes the graph more toward the x-axis. Okay. So if I shrink the red by a factor of 2, it ends up here. So instead of 0, comma, negative 1, it's 0, comma, negative a half. So this is negative a half e to the negative x, like so. Finally, I add 1, right? 1 minus a half e to the negative x. It's just like negative 1 half e to the negative x plus 1. So how do I plus 1? Easiest thing to do is just add 1 to this and just draw the same basic shape. So what's 1 unit higher than 0, comma, negative a half? Go up 1, 0, comma, half. So there's the final answer. I just take this graph, move it up 1 unit, and just draw the same basic shape. Okay, so it's sort of like this. Here's 0, comma, 1 half, y equals 1 minus 1 half e to the negative x. And there we go. Okay. I'm almost done, folks. So we're probably going to be finished early today. 17. Start with e to the x. What's the new equation if I go 2 down, 2 right, reflect about the x-axis, reflect about the y-axis, reflect about both of them? Okay, that should be pretty straightforward. What's 2 down? E to the x minus 2. B, 2 to the right. E to the x minus 2, but the minus 2 is part of the exponent. Okay. Now be careful, these are not the same, and I guess it doesn't matter how you write it. Okay. This minus 2, this 2 is at the same level as the e, but this 2 is floating up here with the exponent. Okay. So this e to the x minus 2, the minus 2 is at the same level as e, but this minus 2 is floating up here. So it's e to the x minus 2 like that. That's 2 to the right. Okay. C, reflect about the x-axis. Okay. So I take a graph and reflect it about the x-axis. It's the opposite of that. So C, y equals negative e to the x. Reflect about the x-axis. How about reflect about the y-axis? There's also a negative, but where's the negative? It's up here. Okay, so D, reflect about the y-axis, e to negative x. Then E should be pretty straightforward. Reflect about the x-axis and then about the y-axis. You do both of them, so you have both negatives. Reflect about both axes, y equals negative e to the negative x, right? So if I just do this, I reflect about the y-axis, then I immediately reflect about the x-axis. I just put a minus sign in front of the whole thing. So negative e to negative x. And in case you're wondering, no, these negatives do not cancel out because this one's in the exponent. Okay. In 19, we have some problems involving domain. So 19a and b. I'll do a for you. F of x equals blah, 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 blah. All right, so the only trouble again is when the denominator is 0. I have to make sure the denominator is not 0. So let's see that one. Okay, f of x equals 1 minus e to the x squared over 1 minus e to the 1 minus x squared. Okay, there's no trouble with the numerator. Numerator doesn't bother me. It's never going to be any trouble. Even if it comes out to be 0, no big deal. I cannot let the bottom be 0, though. So I solve 1 minus e to the 1 minus x squared equals 0. Move this over. That's what that red means. Let me try to emphasize that a little bit. So 1 equals e to the 1 minus x squared. Okay, if I can temporarily cover this up. 1 equals e something. Okay, and you remember how to get rid of the e? You take the natural log of both sides. So ln, ln. ln and e back to back cancel out. Natural log of 1 is 0. So 0 equals 1 minus x squared. Move this over, x squared equals 1. Do the square root property, x is plus or minus 1. Okay. Watch out, sometimes students put the square root and you forget to put the plus or minus. You might just look at it and say, oh yeah, 1. Well, 1 works, but negative 1 also works, doesn't it? So x is plus or minus 1. In fact, let's double check. Look back at the original. If I put in either 1 or negative 1, right? When you square it, you get 1. 1 minus 1 is 0. What's e to the 0? 1. And 1 minus 1 is 0. Okay, so I'm throwing that out of the domain. Again, here's the easiest way to write it. Okay, I want you to get used to this. So the domain is a set of all real numbers minus the set consisting of plus or minus 1. Or you can write negative 1 comma 1. Okay, so this says all real numbers except for negative 1 and 1. So again, I prefer this rather than what? Parenthesis, negative infinity, comma, negative 1, parenthesis, union, negative 1, comma, 1, union, 1 to infinity. That's much longer to write, and it's hard to tell right away when you look at it, hey, what's going on, right? This is very obvious. Take the whole real number 9, throw out negative 1, throw out 1. Okay. Okay, 21, and I'm done, folks. We're done with this section. Little bit different problem. Find the exponential function f of x equals c b to the x whose graph is given. Okay, so they show you it goes through the point 1, 6, and 324. You have to write it so that it looks like c b to the x. Okay, so how do you do that? So f of x equals c b to the x, 1, 6, 324. Now, keep in mind, when I write f of x, that's the same as the letter y, right? This is y. Y equals blah, blah, blah. So 1 comma 6 means x is 1, y is 6. So 1, 6, put a 1 right here, put a 6 right here, 6 equals c b to the 1, right? If this is going to be a point on a graph, that means when I plug in 1 here and I plug in 6 here, I should get a true statement. Likewise for 324, if I put a 3 here and a 24 for y, I should get a true statement. Okay. So 6 equals c b to the 1, 24 equals c b cubed. Okay. If you look at these two, you have two equations and two unknowns, which I can then solve. 6 equals c b, 24 equals c b cubed. Okay. So I need to solve that. The easiest way to solve it, in my opinion, is to divide both sides by 6, but I do it in a very special way. Okay, divide by 6. Here I'm dividing by 6. Take a look back up here. 6 equals CB, so they're equal. So I divided both sides by 6. That way I can get the c's to cancel out. So 4 equals b squared. B is plus or minus 2, but by the rules of the game, for exponential functions, you're only allowed to have positive values. So this time I keep only the b equals 2. Okay, so I plug in 2 right here or here, but this one's easier. Put a 2 here. 6 equals c times 2, so c is 3. So final answer, f of x equals 3 times 2 to the x power. And that's the answer. And let's double check that. If I plug in 1, I'm supposed to get 6. Is that true? Plug in 1, you get 6. And when I plug in, what, 3, I'm supposed to get 24. Plug in 3, 2 cubed, 8. 3 times 8 is 24. So it definitely works. All right, and yeah, in case you're wondering, a quick check of order of operations. No, you cannot change that to 6 to the x power. So, oh yeah, 3 times 2 is 6. Well, this is multiplication. This is an exponent. Exponent has higher priority, so you have to just leave it like that. Okay, I am actually finished, folks. So I'm finished with this section. So starting tomorrow, I'll begin 1.5. But you can see we only have one more section, but it's a pretty big section. Okay, and let me check the chat. Let's see. Okay, some of you put attendance. Okay, I'll get that a little bit later. Okay, yeah. If you're talking about the negative infinity and all that kind of stuff, yeah. So that's fine. Okay, so I think that's about it. So any other questions, folks? Otherwise, I'm pretty much done. Go ahead and put it in the chat. Okay, and thank you, Prasanna. Okay, so on your way out the door, I just want to know, have you had any previous experience with calculus? So just type yes or no or y or n, and then that's pretty much about it. And then you can leave, and I'll see you tomorrow. Okay? So everybody just put yes or no. I have or I have not had some exposure to calculus in the past, and I'll write that also. Okay? Have you taken any calculus in the past, whether high school or college or whatever? Okay, put yes or no or y or n, and then you may leave, and I'll see you all tomorrow. Okay.